Okay. So hello everyone, welcome you all to this session. So here we are going to discuss the AIET 6th class level NEET solutions of chemistry. Okay, so let's start with the first question for today. So it's question number 55 of your question paper. So the correct IUPAC name of the following compound is. So IUPAC based question. So here for naming a compound, we need to find out the longest carbon containing chain, right? So which is the parent chain. And that chain should contain a functional group in it. If a compound contains a functional group, that parent chain should consist of that functional group. So here alkene is the functional group. So the parent chain would be like we have to start from the alkene carbon, double bonded carbon, that is 1, 2, 3, and 4. Okay. So now this is the parent chain. And here bromo is the substituent. And to the first carbon, we have a fluoro and iodo. And to the second carbon, we have chloromethyl as the substituent. Okay, chloromethyl as the substituent. Now, we have to name the compound in accordance with the alphabetical order, right? So, in the alphabetical listing, B comes first. So, it is 4-bromo, 2-chloromethyl, 1-fluoro, and 1-iodo. Since the parent chain contains 4 carbon, it is bute. And the double bond is between carbon 1 and 2, so it is bute 1E. Okay, so 4-bromo, 2-chloromethyl, 1-fluoro, 1-iodo, bute 1E. So that is the answer, and it is given in option B. Okay, so moving on to the next question. The ratio of energy of a photon of wavelength 200 nanometer to that of 400 nanometers. So two wavelengths are given. So this is lambda 1 and we can take this as lambda 2. And we have to find out the ratio of their energy. So we know that energy is inversely proportional to the wavelength, right? So if I want to take the ratio, that is E1 by E2, it will be equal to lambda 2 by lambda 1, right? So lambda 2 is 400 nanometer, lambda 2 is 400 nanometer, and lambda 1 is 200 nanometer. And the ratio that we are getting is 2. So E1 by E2 is equal to 2 by 1. So the answer would be option D. Option D is the answer. The ratio is 2. Okay. Now coming to question number 64. An atom has an atomic number of 13 and a mass number of 27. How many electrons will it have in its valence shell? So in its valence shell, we need to find out the number of electrons present. And the atomic number of the element, that is atomic number Z, is 13. Okay, if the atomic number is 13, then the electronic configuration of that particular element will be 1s2, 2s2, 2p6, 3s2, 3p3, 3p1, 3p1, right? So atomic number is 13, so it is 3p1. And we have three shell, first shell, second shell, and third shell. So third shell is a valence shell, and the valence shell contains how many electrons? 3 electrons. Okay, so the mass number is also 27. So the element is actually aluminium, and number of valence electrons for aluminium is 3. So option C is the correct answer. Okay. Now moving on to question 65. Which orbital has two angular nodal planes? So we need to find out the number of angular nodal planes for the orbitals, and the number of angular nodal planes should be 2. So we have to find it whether it is 2s or 2p or 3d or 4f. So let's start with the thing. So the number of radial nodes can be calculated using the formula. Number of radial nodes can be calculated from n minus L minus 1. And the number of angular nodes is equal to number of angular nodes is equal to L. Okay. So for a given value of n, L will have 0 to n minus 1 value, right? So we need to get 2 angular node. And angular node is nothing but the L. So we should get the L value as 2. Okay, for 2s orbital, n value is 2. This is your n value, and n value is 2. And L corresponds to 0 to n minus 1. Means 0 and n minus 1. 2 minus 1 is 1. So we are not getting 2. Okay, so option A cannot be the answer. And for option B also the same thing. N value is again 2. L value is 0 and 1. And for 3d orbital, n value is 3. N value is 3. Okay, and L value can be 0, 1 and 2. Okay, and here 0 corresponds to s orbital, 1 corresponds to p orbital, and 2 corresponds to d orbital. Okay, so it is 3d. It is 3d. And here L value is 2 for d orbital, and that is the correct answer. That is the correct answer. Okay, and if for a 4f orbital, n value is 4, but L value will be 0, 1, 2, and 3, right? So 0 corresponds to S, 1 corresponds to B, 2 corresponds to D, and 3 corresponds to F. Corresponds to F. So L value is equal to 3 for F. Okay, means L value will be 3 means the nodal plane will be 3. But we have to find out the orbital which has only 2 angular nodal planes. So it is obviously D orbital. Okay. So coming to the next question. The number of moles of oxygen in 1 liter of air containing 21% oxygen by volume in standard conditions is. So we have to find out the number of moles of oxygen. Number of moles we have to find out in 1 liter of air. So now the oxygen present in 1 liter of air is equal to 0.21 liter, right? 21%, it is 0.21 liter. Now to find out the moles of oxygen, therefore the moles of oxygen is equal to the molar volume divided by 22.4, right? So it is equal to 0.21 by 22.4, which will be equal to 0.0093. It is 93 moles. It's 93 moles. Okay. So we are getting option D as the correct answer for this question. So option D is correct. So this is the formula that you are learning from this question. Okay. So coming to the next 68, 10 gram of hydrogen and 64 gram of oxygen were allowed to react in a steam vessel, and the amount of water produced in this reaction will be. So let me write the reaction first. It is hydrogen reacting with oxygen to produce H2. Now, if I want to balance the equation, I have to put 2 here because 2 oxygens are there, and here also we have 2 hydrogen. Okay. Now, let me write the available amount. The available amount of hydrogen is 10 gram. It is 10 gram. And the available amount of oxygen is 64 gram. Okay, this is the available amount. Now we have to find out the number of moles for the system. So the number of moles will be mass by molar mass, right? So the given mass is 10 for hydrogen, and the molar mass of hydrogen is 2. Since we have 2 moles here, we have to multiply it by 2. Okay, so here we will get it is 5 by 2, so it is 2.5. Now coming to the number of moles of oxygen, it is mass is 64 and the molar mass of oxygen is 32. So the number of moles is 2. So now if you see, the oxygen is present in very lesser amount. So oxygen is the limiting reagent. Oxygen is the limiting reagent in this question. Okay. Now that only limits the reaction and it only determines the amount of product that is being formed. Okay. So now in the reaction, if you see, 1 mole of oxygen is producing 2 moles of water. 2 moles of water. Now the number of moles of oxygen is 2 for the given amount, for the available amount. So now the 2 mole of oxygen will give 2 into 2 moles of water. So that is, it will give 4 moles of water. Okay. So the amount of water produced in this reaction will be 4 mole. That is option D. Okay. So from the given amount, we are finding out the number of moles of H2O produced from the given amount of oxygen. Got it? Now coming to the next question. Question number 69. 1 mole of A and 1 mole of B are taken in a vessel and they react according to the reaction 2A plus 3B giving 4C plus 5B. The ratio of the moles of C and D formed will be. So here, for both A and B, 1 mole is taken. So no matter what the initial amounts of A and B are, C and D will always be formed in a 4:5 ratio. Okay, according to the stoichiometric reaction, the ratio of the moles of C and D formed will be 4:5. So no matter what the initial amount of A and B are. Okay, so it will be 4:5. So option C will be the correct answer. Got it? Now coming to question number 70. Which statement this falls for the balanced equation given below? So the equation is there. Carbon disulfide is reacting with 3 moles of oxygen to produce 2 moles of sulfur dioxide and 1 mole of carbon dioxide. So here we have to find out the incorrect statement, false statement. Okay. So let's start from statement A. So 1 mole of CS2 will produce 1 mole of CO2. Yeah, that is correct. Here the number of moles is same. That is correct. And the reaction of 16 gram of oxygen produces 7.33 gram of carbon dioxide. So the ratio for oxygen and carbon dioxide is 3:1, right? It is 3:1. So if 16 gram of oxygen reacts, it will produce 7.33 gram of carbon dioxide. That is also correct. Then coming to option C, the reaction of 1 mole of oxygen will produce 2/3 mole of sulfur dioxide. Yes, the ratio is 2/3, right? It is 3:2. So for 1 mole, it will be 2/3 only. And coming to option D, 6 moles of oxygen requires 3 moles of carbon disulfide. No, the ratio is 1:3. So 1 CS2 reacting with 3 O2. 6 molecules of oxygen means for 6 molecules of oxygen, only 2 molecules of CS2 is required. But here, 3 molecules of CS2 required is given. So that is the incorrect thing. Okay. So option D is false. Option D is false. The ratio is incorrect. Only 2 moles of CS2 is enough to react with 6 molecules of oxygen. Okay. Moving on to question number 71. 50 centimeter cube of 0.04 molar K2Cr2O7 in acidic medium oxidizes sample of H2S gas to sulfur. The volume of 0.03 molar K-4 required to oxidize the same amount of H2S gas to sulfur in acidic medium is. So now, both K2Cr2O7 and K-4, they are the good oxidizing agents. They are the good oxidizing agents. Okay, both are good oxidizing agents. So let me take the oxidizing reaction of this potassium dichromate. So in acidic medium, it takes 14 H plus and it requires 6 electron and it gives Cr2Cr3 plus 7 H2. And coming to oxidizing nature of potassium permanganate, so the permanganate ion takes 8 H plus and it takes 5 electrons to produce Mn2 plus 4 H2. So this is the oxidizing reaction of in acidic medium. Now, we need to find out the volume. For that, we need to find out the concentration. Concentration in terms of molarity, normality we can find out. So the normality of Cr2O7 2 minus, it will be equal to the normality formula is molarity into the number of electrons involved, right? Number of electrons involved, which is nothing but the N factor. So now the molarity, the concentration, molarity in terms of molarity, the concentration of This K2Cr2O7 is 0.04. And the number of electrons involved in that reaction, if you see, it is 6. So the answer will be 0.24 normal solution. And coming to the normality of MnO4 minus, it is also equal to, the molarity is 0.03 and the number of electrons involved in this reaction is 5. So the answer would be 0.15 N. Okay. Now we know that B1N1 is equal to B2N2, right? So let me take the component 1 as K2Cr2O7 and component 2 as KMNO. Okay. So this is the component. Now what is the volume of K2Cr2O7? It is 50 centimeter cube, right? So that is the volume. And the normality is 0.2. And coming to the volume of KMNO4, that only we have to find out. And the normality is 0.15. So from this, on solving this, we will get B2 as 80 centimeter cube. Okay. So this is the volume of KMNO4 required to oxidize the same amount of H2S gas to 7. Okay. So we are using this relation to find out the volume from the normality relation. So two equations you are getting from this. One is the normality formula and the other one is the V1 and V2 V2. Okay. Now moving on to the next question. Question number 72. 0.3 gram of an organic compound containing carbon, hydrogen and oxygen on combustion is 0.44 gram carbon dioxide and 0.18 gram water. If 1 mole of the compound weighs 60 gram, then the molecular formula of the compound is. So what we have to do? We have to find out the molecular formula of the compound. So to find out the molecular formula, we need to first find out the empirical formula of the given species. Okay, to find out the empirical formula, we need to find out the percentage of each element present in the system. So that is not given. So we have to take that first and then we have to find out the empirical formula. Then from the empirical formula, we have to find out the molecular formula. Okay, so there are 3 elements. So let us find out the percentage of each element present in the compound. Okay, so the percentage of carbon is, so the atomic mass of carbon is 12 and the molar mass of this carbon dioxide is 44 into the given mass of the compound is 0.44 and the whole organic compound mass is 0.30. So the mass of the carbon dioxide, mass of that component divided by the mass of the organic total, that component, into 100. So this will give you the percentage of carbon present in the compound, that is 40%. So the percentage of carbon and carbon dioxide we can take. And coming to the percentage of hydrogen in H2O, it is equal to, so H2O, right? So the hydrogen mass is 2 and the molar mass of water is 18 and the mass of H2O is 0.18 and the mass of organic compound is 0.30 into 100. Okay, this is how we have to find out the percentage of an element and it is found out to be 6.6. Now coming to the percentage of oxygen, so it is 100 minus the percentages of carbon and hydrogen, right? So it is 100 minus 40 plus 6.6. It will be equal to 53.4. So these are the percentage. Now let us write the tabular column. So the elements are carbon, hydrogen and oxygen. So the percentage composition is, for carbon it is 40, for hydrogen it is 6.6 and for oxygen it is 53.4. And the molar ratio, that is number of moles, can be calculated using mass by molar mass formula. The mass is 40 for carbon and the molar mass of carbon is 12. So it is found out to be 3.3. And for hydrogen, 6.6 by mass of hydrogen is, atomic mass of hydrogen is 1. So it is 6.6. And coming to oxygen, the mass is 53.4. Molar mass of oxygen is 60. It is equal to 3.3. So this is the molar ratio. Now we have to find out the simplest ratio, right? So to find out the simplest ratio, we need to divide the number of moles by the smallest number. So among 6.6 and 3.3, 3.3 is the smallest one. So divide each molar ratio by the smallest number. It will give you 1 here, and 6.6 divided by 3.3 will give 2, and 3.3 divided by 3.3 gives 1. So from this calculation, the empirical formula is found out to be C1, H2 and O1. Now we need to find out the molecular formula. So to find out the molecular formula, we need to find out the n value. And n is an integer. It is nothing but the molecular mass divided by empirical formula mass. Empirical formula mass. Okay. So the molecular mass is given in the question. It is 60 gram, and the empirical formula mass. In the empirical formula, you see we have 1 carbon and the mass is 12, and 2 hydrogens, so 2, and for 1 oxygen it is 16. So totally we are getting 30. So empirical formula mass is 30 and the n value is found out to be 2. So what we need to do? We have to multiply the empirical formula by 2. So we will arrive at the molecular formula. The molecular formula will be C2 and H4 and O2. So this is the molecular formula of the compound, and it is given in option B. Molecular formula is C2H4O2. Okay. Now coming to question number 73. How many moles of magnesium phosphate Mg3PO4 twice will contain 0.25 mole of oxygen atoms? So here we have to find out the number of moles again. Okay, the formula for magnesium phosphate is Mg3PO4 twice. So here 8 moles of oxygen atoms are present. So we have 4 into 2, right? So since 8 moles of oxygen atoms, we have 8 moles of oxygen atom. So oxygen atoms are present in, since 8 moles of oxygen atoms are present in 1 mole. So in 1 mole of this magnesium phosphate, we have 8 oxygen. Okay. So therefore, here in the question they are asking for 0.25 mole of oxygen atom, right? So 0.25 mole of oxygen atoms are present in 1 by 8 into 0.25 mole of magnesium phosphate. So it will be equal to 3.125 into 10 to the power minus 2 mole of magnesium phosphate. Okay, just cross multiplication. So 8 moles of oxygen are present in 1 mole of this compound, and 0.25 mole is present in how much? So it is the option A. Option A is the correct answer. Okay. Now moving on to question number 75. For an element, various successive ionization enthalpies in kilojoule per mole are given below. The element is. So just observe the ionization energy values given here. So the first ionization energy is 577, and for second it is somewhat around 1000, and third ionization energy is in 2000 value. Fourth ionization energy is in 11,000. So suddenly a large jump is observed between the third ionization energy and fourth ionization energy, right? So the fourth ionization energy is very, very, very larger compared to the third ionization energy, right? So means after the removal of 3 electron, the removal of fourth electron is highly impossible. Means the valence electron of the element should be 3, or we can say it is a trivalent element. Element should be a trivalent element. Trivalent element like aluminium. Okay. So trivalent element like aluminium. So for aluminium, if you see 1s2, 2s2, 2p6, 3s2 and 3p1. So after the removal of these 3 electrons, to remove the 4th electron, we have to go to the inner shell, that is second shell. And it is very closer to the nucleus, and also it is fully filled. So the removal of 4th electron becomes highly difficult, and that's why the 4th ionization energy is very, very high for aluminium. Okay, so aluminium will be the answer. Okay, for silicon, the number of valence electrons are 4. So the 4th ionization energy value will not be that much high. And for phosphorus, we have a 3s2, 3p3 configuration. So we can easily remove the 4th electron from the 3s orbital for that. And for magnesium also it is the same case. 1s2, 2s2, 2p6 and 3s2, right? So the removal of 3rd electron becomes difficult for magnesium. So the 3rd ionization energy should be very high for magnesium, but 4th is very high in this tabular column. So the answer would be option C, that is aluminum. Okay. So coming to question 77, which of the following is the correct order of ionization enthalpy? So now you see we have 4 relations. Okay. First is beryllium plus given higher energy compared to beryllium. So what is the configuration for beryllium plus? It is 1s2, 2s1, right? After removal of 1 electron from s orbital, we will have 2s1. And for beryllium, it is 1s2, 2s2. Now, here if you see after the removal of 1 electron, this is the first shell and this is the second shell. Okay. So in the second shell, we have removed 1 electron and we have only 3 electrons here. Now for beryllium, we have 2 shell number 1 and 2, and in both the shell we have 2 electrons. After the removal of 1 electron from beryllium, that is in beryllium plus, now the outermost electron, that is the 3rd electron, it is more closer to the nucleus. It is more closer to the nucleus. So energy required to remove the 3rd electron from beryllium plus is relatively very high compared to beryllium. So the ionization energy of beryllium plus is more. Okay, in case of this compound 1, first relation. So if relation 1 is correct, relation 2 should be incorrect. So it is obviously incorrect. And coming to relation 3, so the carbon and beryllium, all these elements, boron, beryllium, so all these elements are second period elements. So we know that the ionization energy order for second period element follows this trend, right? That is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So this is what we have there. But there is an exception between beryllium and boron and for nitrogen and oxygen. So actually the ionization energy should increase across the period. But due to the fully filled stable configuration and penetration effect of orbital, so lithium comes first and boron comes next, then only beryllium, then comes carbon, and here also due to the half-filled configuration, oxygen, then comes nitrogen, then is fluorine. Okay, this is the order. And if you see in this order, carbon is having the highest ionization energy compared to beryllium. So compound 3 is also, relation 3 is also correct. And relation 4, boron is having the highest value than beryllium. No, that is incorrect. So that is the exception we observe here in second period element, right? So for this, only relation 1 and 3 are correct, and option C is the correct answer for this. Okay. Now moving on to question number 84. 4 successive members of the first row transition elements are listed below with their atomic numbers. Which of them is expected to have the highest 3rd ionization enthalpy? So vanadium, 3rd ionization energy enthalpy means already 2 electrons are lost. So it is vanadium 2 plus. Vanadium 2 plus configuration is 3d3, 4s0. And for chromium 2 plus, it is 3d4 and 4 is 0. Okay, and for manganese 2 plus, the configuration is 3d5, 4 is 0, and for iron 2 plus, the configuration is 3d6, 4 is 0. Okay, now the highest third ionization enthalpy would be observed for the one which is stable. Now manganese 2 plus is having the stable configuration due to the half-filled d orbital, due to the half-filled d subshell. So due to this particular system is more stable in nature, stability is more, so the energy required to remove the electron from the more stable configuration is higher. Okay, so option C is the correct answer for this question. Now moving on to question 87. Find the ratio of heats liberated at 298 Kelvin from the combustion of 1 kilogram of coke and from combustion of the water gas obtained from 1 kilogram of coke. So coke to be 100% you assume, and the enthalpies of combustion values of all the three gases are also given at 298 Kelvin. Okay. Now the carbon reacts with oxygen to form carbon dioxide. Right. Now here the change in enthalpy value, let me take this as delta H1, and it is equal to, for carbon dioxide, it is equal to 393.5 kilojoule. Now if the carbon reacts with water, it produces carbon monoxide plus H2, which is the water gas. Okay. Now for this delta H2 value, it will be, for carbon monoxide and H2, it is 285 plus 285. Right? So it will be 570 kilojoule. Now we have to take the ratio. We have to find out the ratio of the heat liberated. So delta H1 is to delta H2 ratio. So it is 393.5 is to 570. So the ratio would be 0.69 is to 1. Okay. So this is the ratio and it is given in option B. Moving on to question 89. The temperature of 5 ml of a strong acid increases by 5 degrees Celsius when 5 ml of a strong base is added to it. Now, if 10 ml of each is mixed, temperature should increase by. So, the heat evolved during the neutralization of the 10 ml of each acid and base is twice the heat evolved. Right? So, during the neutralization means mixing of strong acid and strong base results in the neutralization reaction. Right? So now the heat evolved during the neutralization of the 10 ml of each acid and base would be twice the heat evolved from the system. So what happens here? Since the quantity is also getting double from 5 ml to 10 ml, temperature is also increased by 5 degrees Celsius. Okay, here the quantity is increasing by 5 ml. The temperature should also increase by 5 degree. So the option A would be the correct answer. Quantity is double, so the temperature is also increased. Quantity is doubled, so temperature is also increasing by 5 degrees Celsius. Okay. Coming to question number 90. 8.56 liter of an ideal gas at STP requires 24 calorie to raise the temperature by 15 degrees Celsius at constant volume. The CP of the gases. So we know that volume is given and 24 calorie that is given, and it is standard temperature and pressure condition. So everything is given. We need to find out CP. So we know that delta U is equal to NCV delta T, right? And delta U, so the energy is 24 calorie. So delta U is 24 and the number of moles. Number of moles is nothing but the mass by molar mass, we can say. Or here in terms of volume, the molar volume divided by 22.4, right? The molar volume is 8.56 divided by 22.4, and this is the number of moles. And the CV value we do not know, and the change in temperature is 15 degrees Celsius. Okay. Now from this we get CV as 4.187 calorie per mole per Kelvin. Okay. And also we know that Cp minus Cv is equal to R. And from this Cp is equal to R plus Cv, right? So the R value is 2 for in terms of calorie per mole. R value is 2 and Cv value is 4.187. So the answer would be 6.187 calorie per mole per Kelvin. Okay, so this is the Cp value. So the approximate answer would be 6 calorie. So in which option D is the correct answer? D is the correct answer for this question. Now coming to question number 91. A heating coil is immersed in a 100-gram sample of H2O H2O in liquid state at 1 atmospheric pressure and 100 degree Celsius in a closed vessel. In this heating process, 60% of the liquid is converted to the gaseous form at constant pressure of 1 atmospheric pressure. The densities of liquid and gaseous water under these conditions are 1000 kg per meter cube and 0.60 kg per meter cube respectively. Now the magnitude of the work done for the processes. To find out the magnitude of the work done, it is minus P del V. Okay. So we need to find out the change in volume, everything. So from the given data, the mass of water is equal to 100 gram. So here, the mass of water in the liquid state, it is equal to 100 gram. And the density of water in both liquid state and gaseous states, they are given as 1000 and 0.60. So the density of water in the liquid state is equal to 1000 kilogram per meter cube, and the density of water in the gaseous phase is equal to 0.60 kilogram per meter cube. Now, according to the question, the question says that 60% of the liquid is converted to gaseous form. So 60% of conversion took place. 60% of conversion took place. So therefore, the mass of gaseous water formed, it is equal to 60 gram we can say, or in terms of kilogram it is 0.06 kilogram. Okay. Now the volume of the gaseous water formed, H2 in gaseous formed is equal to mass by density, because density is equal to mass by volume. To find out the volume, we can just take this density to the other side, and the given mass is 0.06. Density of the gaseous water, it is 0.6, and it is equal to 0.1 meter cube. We can take this as 100 liter. Okay. Now the volume of H2O in liquid that is being changed, it is equal to 0.06 divided by the density of the liquid water is 1000. Now it is equal to 6 into 10 to the power minus 4 meter cube, which is equal to 0.06 liter. So these are the volume. Now we have to find out the change in volume, right? So the pressure value, it is 1 atmospheric pressure. So what we can take, it is then W. We need to find out this. So W is equal to minus P del V. External pressure is 1. And the change in volume, that is V2 minus V1. So it will be equal to 100, the formed that H2 gaseous state, that volume is 100, and the one which has got reacted, that volume is 0.06 in terms of liter atmosphere. Okay. Now if we calculate this, we will get minus 99.94 liter atmosphere as the W value. Okay. Now we have to convert this to joule, and we have to see the magnitude of that. So to convert liter atmosphere to joule, multiply by the number 100. So W is equal to minus 99.94 into 100 joule. So this will give you minus 9994 joule, and we have to find out the magnitude, right? So take the modulus and it will be 9994 joule. Okay, so this will be the correct answer. So it is given in option C. Option C is the correct answer. Okay. Now moving on to question number 96. Which among the following has hybridization of carbon different from the others? So the marked carbon should have different hybridization from the other three options. We need to find out the correct answer here. So coming to the structure A, it is formic acid HCOOH. And here if you see, it is a double bonded carbon, so it is sp2. Then coming to the next compound, it is urea, CONH2 and NH2. And here also the carbon is double bonded, so it is sp2. Coming to option C, a single carbon is bonded with 3-methyl group with 1 OH. Here all the bonds are sigma bonds, so the hybridization is sp3. Coming to option D, it is CH3, CHO. So CH3, C double bond OH. The double bonded carbon will have sp2 hybridization. So the one that has hybridization different from the others, it is option C. Option C. Coming to question 97, which one of the following arrangements of molecules is correct on the basis of their dipole moment? So three compounds are given. We have to find out the correct order of the dipole moment. So let me draw the structure. So let me draw NH3. So this is NH3 and nitrogen has one lone pair. So nitrogen is more electronegative compared to hydrogen. So all the electrons will move towards nitrogen and the lone pair will pull the electrons towards itself. So here the net dipole moment is towards upward direction. And for NF3, structure is same for NF3 like NH3, but fluorine is more electronegative than nitrogen. So the electrons will be coming towards fluorine. And the lone pair will pull the electrons towards itself. Now here, two equal and opposite directions are there. The net resultant dipole moment will be towards down, but only two bond effects will be there. So this and this, they are equal and opposite, so they will cancel each other. Now coming to BF3, BF3 is trigonal planar in geometry. So here, from all the three sides, equal pulling of electron takes place and the dipole moment becomes 0. Dipole moment mu becomes 0. So that is having the least value. Okay, and here only the 2 NF bond effect is there, and here all the 4 NH bond, everything is going towards upward direction. So NH3 will have the highest dipole moment, then NF3, last is BF3. So it is given in option D. Option D is the correct answer. Now coming to question 98, pick out the incorrect statement from the following. So sp hybrid orbitals are equivalent and are at an angle of 180 degree with each other. So in sp hybridization, so the bond angle will be 180 degree. And in case of sp2, the bond angle is 120 degree. And in case of sp3, the bond angle is 109.5 degree. Okay. Now coming to option B, sp2 hybrid orbitals are equivalent and bond angle between any two of them is 120. Yeah, that is also correct. sp2 is having 120. And all the hybrid orbitals, they will be obviously, they are of equivalent energy only. And coming to option C, sp3d2 hybrid orbitals are equivalent and are oriented towards the corners of the regular octahedron. So sp3d2 is a hybridization of octahedral system, and those orbitals are also equivalent and they orient towards the corner of the octahedron. So if this is atom A, so an octahedron will have 6 atoms around it, and let me take all these as atom B, and here all the orbitals will be pointed towards the atom which is attached with A. Okay, so they are pointing towards the corners. Everything is pointing towards all the orbitals will be pointing towards the corners only. It will be like this and it will be like this. And this is the fourth hybrid orbital. This is the fifth hybrid orbital. This is the sixth hybrid orbital. Okay, so all the six sp3d2 hybridized orbitals are oriented towards the corners of the regular octahedron. That is also correct. Now coming to option D, sp3d3 hybrid orbitals are not equal. No, all hybrid orbitals are in equal energy. So that is the thing we studied, right? All the hybrid orbitals, they are equivalent. They are equivalent. So here it is given not equivalent. So that is the incorrect statement. All the hybrid orbital, whether it is sp or sp2, sp3d2, anything it can be, they are all in equivalent energy. So that is a rule for hybridized orbital. So since here in option D, it is given as non-equivalent, that is the incorrect statement. Okay. So moving on to question 99. Which one of the following species is diamagnetic in nature? So we know that from the molecular orbital theory, if I want to draw the MO diagram, so energy goes like this, and this is the 1s orbital of hydrogen, which has 1 electron, and this is the 1s orbital of second hydrogen, which has 1 electron. 1s1, 1s1. Now they both will form the molecular orbital, right? And this is sigma 1s, and this is sigma star 1s. So two electrons will occupy the sigma 1s orbital according to the Aufbau principle. So the electronic configuration is sigma 1s2. So two electrons are present for hydrogen molecule. The two electrons are present in sigma 1s orbital and they are paired with each other. So it is diamagnetic in nature. Diamagnetic in nature. So in case of helium 2 plus, we will have one electron in sigma star 1s. In case of H2 plus, we will have only one electron in sigma 1s. Okay. For helium 2 plus, you will have two electrons in sigma 1s, but only one electron in sigma star 1s. So since we have one electron, it is paramagnetic in nature. And coming to hydrogen plus, one electron is removed from hydrogen, right? So we have sigma 1s 1 only. So again, it has unpaired electron, so it is paramagnetic. And coming to H2 minus, we have to add one electron to the hydrogen molecular orbital diagram. So we will have sigma 1s2 and sigma star 1s1. So the third electron will go to that antibonding orbital, and it also contains unpaired electron, so it is paramagnetic. So the species that is diamagnetic in nature is H2. Okay. Coming to the last question of today's session, the IUPAC name of the compound. So now we have to find out the parent chain, right? The parent chain should contain the functional group. And here we have two functional group, one is alkene and alcohol. But alcohol gets a first preference because it is having the highest priority compared to alkene. So the OH containing carbon should get the lowest number. So I have to go like this. So this carbon is numbered 1, this is 2, 3, 4 and 5. Okay. Now this substituent is methyl. So it is 3-methyl and parent chain contains 5 carbons. So it is pent. Between 3 and 4 we have a double bond. So pent 3-ene and to the second carbon we have the OH. So 2 all. 3-methyl, pent 3-ene and 2 all. So option A is the correct answer for this question. So I hope this session is very useful and all the questions that I have discussed are clear to all of you. So I'll meet you all in the next session. So thank you so much for listening the class. Thank you. Bye bye.